In this lesson, we will discuss the fundamental theorem of calculus. What is the fundamental theorem of calculus about? It gives you a method of evaluating a definite integral. Now, what is the difference between a definite integral and an indefinite integral? A definite integral is a measure of the area enclosed by the graph of the function with the x-axis on a given interval from a to b. Indefinite integral does not give you any definite interval. Now, fundamental theorem helps us to find the value of a definite integral. But before we go on to that, let's review some of the basic integration formulae that we already know. Alright, tell me, what is integral of 0 dx? What do you get if you integrate 0? Well, how do you know? Well, you know because the derivative, what is the derivative of a constant? The derivative of a constant is 0. Now, remember, we have said this several times already, that finding the integral of a function is opposite to finding the derivative. If the derivative of a constant is 0, then integral of 0 must be equal to a constant. Integrating 0 gives you a constant. Now, what is integral of dx? Integral of dx. Integrate means add them all up. Integrate dx will give you x. Integral dp will give you p. Integral dt will give you t, and so on. What is integral a dx? Where a is a constant number. Integral 5 dx. Integral 7 dx. It is, well, we forgot one thing here. Can you remind me what is that we forgot? If you integrate dx, because the derivative of a constant is 0, we know that integral of 0 is a constant. And therefore, integral of dx is the same as, let me rewrite this. Integral of dx is the same as integral of dx plus 0. Adding 0 doesn't change anything. So, integral of dx and integral of dx plus 0 is the same thing. And therefore, integral dx is x plus c. Integral of 0 is c. Similarly, integral a dx is the same as integral a dx plus 0. We don't normally write it, that is understood. Therefore, integral a dx is ax plus c. So, whenever you integrate a function, you need to add a constant c. You know why it is done. Alright, what is our power rule that we talked about earlier? Integral x to the power of n dx is x to the power of n plus 1 over n plus 1. Now, we will use this rule a lot in this lesson and in lessons to come. Alright, can you use the power rule and tell me what the integral of this is? Integral x to the power of 3 over 2 dx. It will be x to the power of 3 over 2 plus 1 over 3 over 2 plus 1. And that will be x to the power of 3 over 2 plus 1 is 5 over 2 divided by 5 over 2. Now, when you divide by a fraction like 5 over 2, you reverse and multiply. That means this is the same as dividing by 5 over 2 is the same as multiplying by 2 over 5. That means the 5 will stay in the denominator and the 2 will go up. So every time we have a situation like this, I will not be writing 5 over 2 on the denominator. I would say divided by 5 over 2, that over 2 will go to the numerator. That's right. So that will be 2x to the power of 5 over 2 over 5. Alright, quickly tell me, what is integral x to the power of 7 over 3 dx? X to the power of 7 over 3 dx. Well, that will be, can you write that in one step? It will be x to the power of, let's write it one more time. X to the power of 7 over 3 plus 1 over 7 over 3 plus 1. And what is that equal to? What is 7 over 3 plus 1? Will be 10 over 3. And that will be x to the power of 10 over 3 divided by 10 over 3. It will be 10 divided by 3 means 3 goes up. It will be 3 x to the power of 10 over 3 divided by 10. And you need to practice this. We will be using this very often. Now tell me, what is the meaning of, say, integral 0 to 4 x dx? What does that mean? Integral 0 to 4 x dx. It means it gives you a measure of the area enclosed by the graph of f of x equal to x with the x-axis from x equal to 0 to x equal to 4. That's the meaning of that. Well, if I draw a graph of that, it will look like this. How does the graph of f of x equal to x look like? This is the graph of f of x equal to x. Is that right? Or we call it y equal to x. Now, we've got 1, 2, 3, 4. So the area enclosed by f of x dx with the x-axis will be this area. This is x equal to 4. Tell me, if x equal to 4 is this, what is the value of y? We get y equal to x is our function. That means whatever input is the same as the output, y equal to x. So this point is actually x equal to 4, y equal to 4. That means the base of this triangle, if you look at this, that area is a triangle. The base of that triangle is 4 units, and the altitude or height of that triangle is also 4 units. What is the area of this triangle? Area of this triangle is 1/2 of base multiplied by height. And that will be 8 square units. The area of this triangle is 8 square units. That means the value of this integral must be 8. Is that right? Integral 0 to 4 x dx is the area enclosed by the graph of y equal to x from x equal to 0 to x equal to 4. So this is actually equal to 8. Now, we are going to see how fundamental theorem will help us to evaluate this. You see, in every case, we cannot draw the area like this. This is a very simple area to draw. In most cases, you cannot really evaluate an area because the area will be very complicated. The fundamental theorem actually gives you a method to do this. All right, let's see what the fundamental theorem is. Let me take this off. Now the fundamental theorem says, if you want to say evaluate integral lowercase f of x dx, say if integral f of lowercase f of x dx is called uppercase f of x. Suppose we call it like this. For example, you integrate sine x, what do you get? Integrate sine x dx, don't forget that, with respect to x. You get negative cos x. Now when you translate into this statement, lowercase f of x dx is sine x, and uppercase f of x dx is negative cos x. In other words, lowercase f of x dx is the function that we want to integrate. The uppercase f of x is the function that we have obtained by integrating lowercase f of x dx. I hope you understand it. Now, once you have this, the fundamental theorem says integral a to b of f of x dx equal to uppercase b minus uppercase a. In other words, what all this means is, once you integrate a function, you got the integrated version. To find a definite integral, first replace x by the upper limit and then subtract by replacing x by the lower limit. That's the meaning of this statement, and this is the statement of the fundamental theorem of calculus. Alright, let's practice it here. Tell me, which is our lowercase f of x in this case? F of x equal to x is the lowercase. What is our uppercase? Well, I'm going to take that off. What is our uppercase f of x? Can you integrate x dx for me? You will get, using the power rule, it will be x squared over 2, and say plus c. Now, this is your uppercase f of x. So in order to find the value of this definite integral, what all we need to do is replace x by the upper limit first. So let's do that. That will be, replace x by 4. 4 squared divided by 2 plus c. That will be your f of b. Replace, in the integrated function, replace x by the upper limit and then subtract. Subtract what? F of a. In the integrated function, replace x by the lower limit is 0. 0 divided by 2 plus c. Now, what does that give you? This will be 4 squared is 16. 16 divided by 2 is 8. 8 plus c, that will be 0 minus c. And you notice that the c's actually will cancel. Now, this will happen in any definite integral. The c from the upper limit value will cancel with the c in the lower limit because of the subtraction. That means when you do a definite integral, we don't need to do the c. We can do away with the c. We need c only for an indefinite integral. Now, is it because there is no c? No, always there is a c when you integrate. But for a definite integral, that c will cancel from the upper limit quantity subtracted with the lower limit quantity. The c will cancel. So we don't need to write that. So we can see the answer is 8, which is the same as the answer we got from the area calculations. So from now on, we will be using this method to evaluate a definite integral. I think that's better, is that right? Alright, let me see if you remember some of the standard integrals that we used earlier. Tell me, what is integral of sine x dx? Well, you know that the derivative of cos x, the derivative of cos x is negative sine x. Therefore, if you integrate sine x, you must get negative cos x. So that will be negative cos x plus c. Alright, what is integral of cos x dx? The derivative of sine x is cos x. Therefore, integrating cos x must give you sine x. Very often students confuse it, especially the sine, because in the derivative of sine x is positive cos x. But when you integrate, integral of sine x is negative cos x. Why? Because the derivative of cos x is negative sine x. That's why. Now, can you integrate tan x? It's rather tough, isn't it? Because we haven't come across a quantity when you find the derivative, the answer will be tan x. That's difficult to find. So integrating tan x is not easy. Now, give me another trigonometric function whose derivative that you know. What is the derivative of tan x, for example? What is the derivative of tan x? The derivative of tan x is secant squared x. Therefore, we can integrate secant squared x. Integral of secant squared x dx is tan x plus c. Well, another derivative that you know is the derivative of secant x. What's the derivative of secant x? The derivative of secant x is secant x tan x. Therefore, we can integrate secant x tan x dx. And what's that equal to? Integral of secant x tan x dx equal to secant x plus c, because the derivative of secant x is secant x tan x. Now, how about the derivative of cosecant x? What is the derivative of cosecant x? It's negative cot x cosecant x. Therefore, what is integral of cot x cosecant x dx? Integral of cot x cosecant x dx is negative cosecant x plus c, because the derivative of cosecant x is negative cot x cosecant x. Well, think of another derivative that you know of a trig function. What is the derivative of cot x? Derivative of cot x is negative cosecant squared x. Therefore, what is integral of cosecant squared x dx? That will be negative cot x plus c. Well, these are some of the integrals. You need to really remember them. And very often we will be using them. Alright? Okay. Let's do a simple problem using the fundamental theorem. Find the value of integral 1 to 3 x squared dx. Integral 1 to 3 x squared dx. Now, first of all, what are the steps that you need to take? First of all, integrate the given function so that you get the uppercase f of x. And then what? Then, in the uppercase f of x, set x equal to the upper limit and then minus, in the uppercase f of x, set x equal to the lower limit, and then simplify. Alright, so what is the uppercase f of x here? Integrate this. X squared dx integrated will give you x cubed over 3. And I want you to watch how we're going to, once you integrate it, now remember, we have, this is what is called the operator. This is an operator. Now, this operation has been done. That means we don't put that sign again here. This quantity has been integrated. But we need to take care of the limits. How do you do that? Now watch me do that. Put a bracket and put the lower limit and the upper limit like this. So once you have integrated, this is the integrated value, and that should go from x equal to 1 to x equal to 3. Now what's the method now? This is our uppercase f of x. Now on this, replace x by 3, the upper limit. So that will be 3 to the power of 3 over 3 minus, replace x by the lower limit. That will be 1 to the power of 3 divided by 3. Now what is 3 to the power of 3 divided by 3? Isn't that 9? Yes, so that would be 9 minus 1/3, and 9 minus 1/3 will be, give me quickly a value for that. It will be 26 over 3. Is that right? So integral 1 to 3 of x squared dx is 26 over 3. The area enclosed by the graph of x squared dx from x equal to 1 to x equal to 3 is this value. Alright, let's try this. Integral 0 to 3, 3x squared plus x minus 2 dx. The first thing to do is to integrate this quantity, and that will be 3 is a constant, that will remain there. X squared integrated will give you x cubed over 3. So that will be 3 times x cubed over 3 plus integrate x. Integral x is x squared over 2 minus, what is integral 2 dx? Integral 2 dx is 2x. Now, once we have integrated, remember we have finished with that operation. So don't put that symbol again. That symbol means integrate. We have integrated. Now, how do we put the limit? Now, put a bracket at the end and say the lower limit is 0, the upper limit is 3. Okay, now what we need to do is, you can see a small simplification. 3 and the 3 can go. First, set x equal to 3, and that will be, you start with a parenthesis. In other words, you're going to use the upper limit value first. Set x equal to 3 first. What does that give you? X equal to 3 gives you 3 cubed plus 3 squared over 2 minus 2 times 3. Now that is the upper limit. Now look at that parenthesis there. That's the whole thing is for the upper limit. Minus the lower limit. You put x equal to 0. Each of these will go to 0. So the value of all these when x equals 0 will be 0. So you don't need to worry about it. Now that will be 3 cubed is 27 plus 9 over 2 minus 6. And that will be 54 plus 9 minus 12 over 2. Is that right? Okay, what is the simplified form of that? Is that 51 over 2? Check this out. That will be 51 over 2. Okay, let's try this one. Integral -8 to -1 x minus x cubed over 2 cube root of, well, it's not cube root of 8, cube root of x. Well, there are a couple of things that you can do to start with. First of all, this 2 is a constant. We can actually take it out. It'll become a 1/2. So that will be 1/2 integral -8 to -1 x cubed, no, x minus x cubed. So that will be x minus x cubed over cube root of x. Can you write it with a rational power? Cube root of x is x to the power of 1/3. Now, in our next step, what we need to do is, remember, we only know one rule to find the integral of a function. That is the power rule. So you need to bring each term in the form of a power so that we can use the power rule. So what we need to do is split this into 2 terms. So that will be integral. Now you should see that we haven't integrated yet, so we need to continue using the operation sign. Integral -8 to -1. This will be x over x to the power of 1/3. Is that right? Minus x cubed over x to the power of 1/3. We split into 2 terms. All right, I'm going to now start here. That is, what is x divided by? Well, we still have an integral, so I need to say integral -8 to 8. What is x divided by x to the power of 1/3? X divided by x to the power of 1/3 is x to the power of 2/3 minus what is x cubed divided by x to the power of 1/3. X cubed divided by x to the power of 1/3 will be x to the power of, all right, I'm going to give you a second. Think about it and tell me what it is. 1 minus 1/3, 3 minus 1/3 is 8/3. So that will be x to the power of 8/3 dx. So we have now simplified by splitting this into 2 terms, and then we wrote each with a single base, which means we can now integrate each of these terms using the power rule. Now we are going to get rid of this sign because we are now going to do the operation. Now tell me, what is integral of x to the power of 2/3? It will be x to the power of 2/3 plus 1. Let's write that step. It will be x to the power of 2/3 plus 1 over 2/3 plus 1 minus integral of x to the power of 8/3 will be x to the power of 8/3 plus 1 over 8/3 plus 1. All right, let's continue here. What is 2/3 plus 1? 2/3 plus 1 is 5/3. So that will be x to the power of 5/3 divided by, look at the denominator, 2/3 plus 1 is 5/3. So divided by 5/3, 5 divided by 3, that 3 goes up. Minus yes, We got x to the power of 8 thirds plus 1. What is 8 thirds plus 1? 8 thirds plus 1 is 11 over 3. So now this is what we have. 3x to the power of 5 over 3 over, well, you notice I made a small mistake. We had multiplied by 2, so that becomes 10, and this becomes 22. Alright, now we've got the lower limit -8 and the upper limit -1. So what we do is first replace x by the upper limit. Replace x by -1. So that will be 3 times -1 to the power of 5 thirds over 10 minus 3 times -1 to the power of 11 over 3 divided by 22. This is the upper limit. We have replaced x by the upper limit. We now need to subtract by replacing x by the lower limit, and the lower limit is -8. So that will be 3 times -8 to the power of 5 thirds divided by 10 minus 3 times -8 to the power of 11 over 3 divided by 22. That is the lower limit. So replace by upper limit minus replace x by the lower limit. Now we need to simplify this. Can you help me do that? Do you want to take a second and try and do it on your own? Alright, what does that give you again? That will be 3 times. Now look at the way you're going to read this. When you have a rational power 5 over 3, the denominator gives you the type of root. So you must read it like this. -1, let me write it for you. -1 to the power of 5 thirds is the same as cube root of -1, cube root of -1 all to the power of 5. That's the meaning of that. So -1 to the power of 5 thirds, cube root of -1, which is -1, raised to the power of 5, which is -1. -1 raised to the power of 5 is -1. Similarly, let's try this. What is -8 raised to the power of 11 over 3? -8 raised to the power 11 over 3 will be, the denominator is 3, that means cube root of -8. That would be cube root of -8 and raise that to the power of 11. And what is that equal to? What is cube root of -2? Oh, I'm sorry, -8 is -2. -2 times -2 times -2 is -8. So this will be -2 raised to the power of 11. And what is -2 raised to the power of 11? Well, it's an easy number. It's 2048. 2 to the power of certain numbers is rather easy to compound. So this quantity is actually 2048. All right, let's write down those values. So this will be 3 times -1. Again, look at the way cube root of -1 is -1. -1 to the power of 5 is -1 divided by 10 minus 3 times, tell me what this is, -1 to the power of 11 over 3. They are both odd numbers. Cube root of -1 is -1. -1 to the power of 11 is also -1. So that would be 3 to the times -1 over 22 minus. Now, here I did not put the parenthesis, there is no need, but here after the negative sign you need to. Alright, tell me this. Negative 8 to the power of 5/3. Cube root of negative 8 is negative 2, and that raised to the power of 5. Can you tell me what this is? Negative 2 raised to the power of 5 will be negative 32. Let's leave it like that for the time being. By 10 minus 3 times what we say this is. Negative 8 cube root of that is negative 2. Negative 2 raised to the power of 11 is negative 2048 over 22. And let's simplify that. That will be negative 3 over 10. And if you look here, this negative 1 with the negative sign will become positive, plus 3 over 22. And here, can you do this in your mind? Or let's do it one more time. Minus 3 times negative 2 raised to the power of 5 is negative 32. And negative 32 times 3 is negative 96 divided by 10 minus, what is 3 times 20? 48. 3 times 20, 48 is 6144. That is negative. Negative 6144 divided by 22. And now distribute that negative. That gives you negative 3 over 10 plus 3 over 22 minus become positive plus 96 over 10. And here 2 negatives make it positive, but this negative makes it negative. Minus 6144 divided by 22. And I think I'm going to leave it there for you to find the common denominator and simplify that on your own. That's an elementary algebra problem. Now, did you get it as 14,766 divided by 55? Let me know if that is right or if there is a problem with it. Well, you should practice working out these kind of problems. Now let's look at this integral. Now, is there any way to integrate this quantity? Have we learned a method of integrating something as complicated as this? Well, I can say for sure that we haven't. So, why did I ask you about this? Well, because you must be able to look at this function and tell me what the graph of that looks like. Tell me what is the graph of square root of 4 minus x squared look like. If you recall, we have discussed this some time ago. How about this? X squared plus y squared equal to 4 is the equation of a circle, and this is that circle, and the radius of that circle is what? X squared plus y squared equal to 4 is the same as 2 squared. The radius of that circle is 2. Now, if you solve this for y, you get y equal to plus or minus square root 4 minus x squared. In fact, y equal to square root 4 minus x squared is the upper part of the circle, and y equal to negative 4 minus x square root 4 minus x squared is the lower part of the circle. Therefore, this is the origin. Radius equal to 2, therefore this is negative 2 and this is positive 2. So the definite integral defined by this integral negative 2 to 2 of square root 4 minus x squared dx is the upper part of the area of the circle. In other words, it is half of the area of a circle of radius 2. Now, what is the area of a circle of radius 2? It will be pi r squared. Pi times 2 squared, that is 4 pi. 4 pi is the complete area. Therefore, what is the top part? The top part will be 2 pi. And so, integral negative 2 to 2 of square root 4 minus x squared is 2 pi. We visualized it by looking at the geometrical interpretation of the graph of this function. Is that right? That is a perfectly acceptable way of doing a definite integral. Alright, let's try this now. Integral negative pi by 2 to pi by 2, 2t plus cos t dt. Well, the first thing to do is integrate the function. Tell me, what is integral of 2t? Integral of 2t is 2 times integral of t. Integral of t dt is t squared over 2. So that will be 2 times t squared over 2 plus, what is the integral of cos t? Integral cos t is sine t. So that will be plus sine t. We have finished integration, so we don't need the sign again, but use the limits. It will be negative pi by 2 to pi by 2. And that will be, let's do it from here. Here, that will go. And so it will be t squared plus sine t, t squared plus sine t, negative pi by 2 to pi by 2. Alright, help me evaluate this. First, put the upper limit. Replace t by pi by 2. When t is pi by 2, t squared is pi squared over 4. So this will be pi squared over 4 plus sine of t, sine of pi by 2. That is the upper limit, minus, always remember to use that parenthesis after the negative sign, minus lower limit. When t equal to negative pi by 2, t squared is positive pi squared over 4. That will be pi squared over 4 plus sine of negative pi by 2. What is sine of negative x? Well, those are results that you must know. Sine of negative x is negative sine x. So, sine of negative pi by 2 is negative sine of pi by 2, which is, and I'm going to write it like that, negative sine of pi by 2. And that's equal to pi squared over 4 plus sine pi by 2 is 1. That is the upper limit, minus pi squared over 4, sine pi by 2 is 1, that negative sign, that will be negative 1. And you can actually simplify that right away. This is pi squared. Pi squared over 4 minus pi squared over 4 will cancel. This is plus 1, look at this, minus become positive. 1 plus 1, so the answer here is 2. Alright? Very simple. Okay, let's look at this problem. Find the area of the region bounded by the graphs of y equal to 1 plus square root x equal to 0, x equal to 4, and y equal to 0. Well, how does the graph of y equal to 1 plus square root x look like? Well, you know how the graph of f of x equals square root x is. Now 1 plus means it will be shifting 1 unit upward. So the graph of 1 plus square root x will be, you see, square root x will be like this. 1 plus square root of x will be that. Now, we need to find the area of the region bounded by y equal to 1 plus square root of x. This is y equal to 1 plus square root of x. X equal to 0. X equal to 0 is the y-axis. X equal to 4. 1, 2, 3, 4. This is x equal to 4. And y equal to 0. Y equal to 0 is the x-axis. You see? So what we are required to do is to find this area. This is the area that we are looking for. Now, can you write this as a definite integral? Well, it is actually a very simple definite integral. It is the area enclosed by the graph of y equal to 1 plus square root x with the x-axis from x equal to 0 to x equal to 4. Therefore, we have it as integral 0 to 4 of 1 plus square root x dx. That is what we have been told to find. Very simple, is that right? Okay, let's evaluate that. Now remember, square root of x is x to the power of 1/2. So this will be integral 0 to 4, 1 plus x to the power of 1/2 dx. Now, what I'm going to do is I'm going to take off all these and we will start from here and see how we can evaluate that, alright? Alright, help me evaluate that. Integral 0 to 4, 1 plus x to the power of 1/2 dx. And that will be, integrate each term. Integral 1 dx will be x plus integral x to the power of 1/2 dx will be x to the power of 1/2 plus 1. What is 1/2 plus 1? 1/2 plus 1 is 3 over 2. So this will be x to the power of 3 over 2 divided by 3 over 2. The integral of x to the power of 1/2 is x to the power of 3 over 2 over 3 over 2. There you go. Now that goes from x equal to 0 to x equal to 4. And let's find the value of that. First, to replace x by 4. That will be 4 plus 2 times 4 to the power of 3 over 2 over 3. That is the upper limit minus. The lower limit is 0. When you replace x by 0, both terms will be 0. So that will be simply 0. Alright, find that value. That will be 4 plus 2 times. Look at this again. The power is 3 over 2. The denominator of the rational power is 2, which means you need to take the square root of this. So square root of 4, then raise it to the power of 3. Square root of 4 is 2. 2 to the power of 3 is 8. So that will be 2 times 8 divided by 3. And that's equal to 4 plus 16 over 3. And what's that equal to? That will be 12 plus 16 over 3. And that will be, what is 12? That'll be 28 over 3. Is that right? That's right. So integral 0 to 4 of this quantity is 28 over 3. The area enclosed by y equal to 1 plus square root x, x equal to 0, and x equal to 4 with y equal to 0 is 28 over 3 square units. Okay. We will now discuss the meaning of average value of a function f of x in the closed interval x equal to a to x equal to b. Now, I'm going to give you the results of this. The average value of a function f of x is given by, in other words, average value of a function f of x is given by, on the interval ab, is 1 over b minus a integral a to b of f of x dx. This is the definition of average value of a function on the closed interval from a to b. It is 1 over b minus a integral a to b of f of x dx. We are now going to use this to solve a couple of simple problems. Alright, we need to find the average value of a function f of x equal to x squared plus 1 over x squared on the interval x equal to 1/2 to x equal to 2, both endpoints included. Now, what is the definition of average value of a function? Average value is 1 over b minus a integral a to b of f of x dx. So, let's do that. We say average f of x equal to 1 over b minus a, 2 minus 1/2, integral a to b, 1/2 to 2, f of x dx, x squared plus 1 over x squared dx. Alright, first of all we need to evaluate that. Tell me, what is 2 minus 1/2? 2 minus 1/2 is 3 over 2. 1 over 3 over 2, can I write it like this? It is 2/3. So 1 over 2 minus 1/2 is actually 2/3. 1 over 3 over 2, which is 2 over 3. Integral, let's write one more step. Integral 1/2 to 2. Now, remember, in order to integrate functions like this, you need to write them in the power form, because the only rule we know for integration is the power rule. So we need to split this into 2 pieces. So that will be x squared over x squared plus 1 over x squared. It will be x squared over x squared plus 1 over x squared dx. Now, let's write one more step. That will be 2/3 integral 1/2 to 2. What does this simplify to? That will be 1 plus 1 over x squared, we need it in the power form, is x to the power of -2 dx. Now, this is what we need to evaluate. So, I'm going to start with this over here as I clean off some of these steps. Okay? So, this is what we want to find the value of. And let's now find the integral of this. 2/3 is a constant. We can, first of all, take it out. So that will be 2/3 times integral of 1 dx is x. Tell me, what is the integral of x to the power of -2? Let's do it here. X to the power, integral x to the power of -2 is, use the power rule, x to the power of -2 plus 1 over -2 plus 1. Integral x to the power of n is x to the power of n plus 1 over n plus 1. And that will be x to the power of -1 over -1. And that's equal to, Can you give me a simplified form of that quickly? X to the power of -1 is 1 over x. And with this negative, you get -1 over x. Now, you could have given the answer that straight away. You know that the derivative of 1 over x is -1 over x squared. Therefore, integral of 1 over x squared is -1 over x. That's right. So, integral 1 dx is x, and integral of x to the -2 dx is -1 over x, and the lower limit is 1/2 and the upper limit is 2. Now that will be 2 over 3 times, let's put a bracket there, let's use the upper limit. You put x equal to 2 and you get 2 minus 1/2, the upper limit, minus, the lower limit will be 1/2 minus, look at that, when x equal to 1/2, it will be 1 over 1/2. What is 1 over 1/2? It is 2. That's right. So, it will be 2 minus 1 over 2 minus, x equal to 1/2 gives you 1/2 minus 1 over 1/2 is 2. And that will be 2/3 times 2 minus 1/2, let's leave it like that, 2 minus 1/2 minus 1/2 plus 4, that makes it very simple. Now, well, that's plus 2, not 4. Now, 2 plus 2 is 4, that's what I had in mind, so my mind works a little faster. 2 plus 2 is 4, and -1/2 is -1. 4 minus 1 is 3, and look at that, this is 3, and 3 and 3 will cancel, so the answer is actually 2. The value of this, the average value of the given function on the interval 1/2 to 2 is actually 2. That's what it means. Okay, try this now. The velocity v of the flow of blood in an artery of radius r at a distance lowercase r from its center is given by v equal to k times uppercase r squared minus lowercase r squared. Find the average rate of flow of blood in the artery. And here k is a constant, k is just any number. Now, if you notice, artery is a tube. If you draw that, let's draw the artery. How is it like? It's going to be something like this. That's the artery. And we are told that the radius of the artery is uppercase R. Now, blood is flowing through the artery. Now, will the speed of blood be the same at every point? Now, if you know something about flow, you know that when water flows in a tube, the points where the water is touching the tube, the flow rate will be slower. And as you move towards the center of the tube, water will be moving faster. Why? It's because of the forces exerted by the tube on water. In the same way, as blood moves through the tube, the speed, now I'm going to represent the speed by using arrows. Now, the speed of blood here is indicated by that arrow. As you go closer and closer to the wall of the tube, you can see that arrow becomes shorter and shorter, means the speed of flow becomes smaller. The speed will be slower as you move away from the center. Now you should notice that the uppercase R, which is the radius of the tube, remains a constant. We are told that this expression is for the speed of blood at a distance r from the center. This is the distance, this is the center, and that's the distance r. At a distance r, the speed is this. Now tell me, what is the speed of blood along the wall of the vessel? Now, if you take a point on the wall, then lowercase r is the same as uppercase R. Then r squared minus r squared will be 0. The speed is 0. So, the flood will not be flowing along the wall of the vessel at all. The cells of the blood will be almost at rest. As you move away from the wall, the speed is greater and greater. The maximum speed is when this r equal to 0. This r equal to 0 is at the center. When this r equal to 0, you got the maximum flow rate. That's the meaning of this. Now, so the question is, what is the average flow rate? If you want to talk about how much blood flows through the vessel in a certain amount of time, we need to know the average flow rate. All right, now the average flow rate is the average value of this function. What is the average value of a function? We want V average. So V average is 1 over B minus A. What is our limits here? What are the values, what are the limits where R can change? R is 0 here, at the center here, R equal to 0, and at the wall of the blood vessel, that R is the same as the radius. Is that right? That means this R changes from 0 to uppercase R. So that is our limits of integration. So you need to therefore have the interval 0 to r. We need to find the average value of this function on the interval 0 to r, and therefore the average value will be 1 over b minus r, 1 over r minus 0, integral lowercase 0 to r times the function k times r squared minus r squared dr. Look at that. This is lowercase r is our variable. Uppercase r is a constant. You've got to understand that. Alright, let's work it out. I'm going to start working it out from above the... Alright, remember our function is v equal to k over r squared minus r squared. And we can take that k outside. So what we want to evaluate is this k over r minus 0 integral 0 to r times r squared minus r squared dr. Now help me evaluate that. That will be k over uppercase r minus 0 is k over uppercase r. And now you should understand the uppercase R is a constant. And you should know that integral a dx is ax. Is that right? So integral r squared dr is r squared r. The big R squared is a constant. This is the variable. So this will remain the same. R squared times r, let's put the parenthesis, minus integral lowercase r squared dr is r cubed over 3. Now very often students make the mistake here because you see r, you think it's a variable. Now the integral of uppercase r squared dr is not uppercase r cubed over 3. Why? Because uppercase r is a constant. It'll be r squared r minus r cubed over 3, and the limits go from 0 to r. Let's now apply the limit. That will be k over r times, let's put the lower limit. The lower limit means the lowercase r is replaced as r. So when this lowercase r becomes the uppercase r, this becomes r cube minus, when the lowercase r is uppercase r, that is also r cube. So that will be uppercase r cube minus uppercase r cube over 3. That's the upper limit. Minus, what will be the lower limit? When r equal to 0, this will be 0, that will be 0. So that will be 0. And that's equal to, what is r cube minus r cube over 3? That will be 2r cube over 3. Is that right? That will be k over r times 2r cube over 3. And 1r will cancel, leaving us with the answer 2/3 k r squared. This is the average rate of flow of blood in the blood vessel. Okay. If you check the slide number 27 in the PowerPoint, you will see the complete statement of this question. But the question says, the graph of this function, the area enclosed by the graph of this function, from x equal to 1 to x equal to x, is given by this function, a of x. Although this is a function of t, when the area is measured along the x-axis from x equal to 1 to x, it becomes a function of x. Now, we are told that find a as a function of x and find its asymptotic behavior. Well, we have talked about asymptotes before, and we know what the meaning of asymptotic behavior. Is that right? Well, what we need to do is find this integral. First of all, we integrate this function with respect to t. Is that right? Now, okay, help me integrate this function with respect to t. And then we apply the limit. So that will be, what is integral of 4 dt? Integral of 4 dt is 4t. And now, let me see if you remember. Look at this. The derivative of 1 over t with respect to t is negative 1 over t squared. Is that right? Therefore, integral of 1 over t squared is negative 1 over t. Can you tell me what will be the integral of 4 over t squared? 4 is a constant. It is 4 times 1 over t squared. I'm going to repeat that one more time. Now, when you do calculus, you've got to keep your mind active. The derivative of 1 over t with respect to t is negative 1 over t squared. Look at that, negative 1 over t squared. Therefore, what is the integral of negative 1 over t squared? Is 1 over t. So, the integral of negative 4 over t squared dt is actually 4 times 1 over t, or 4 over t. Now, if you have difficulty, just go the reverse way. Find the derivative. Derivative of 4t with respect to t is 4. The derivative of 4 over t with respect to t is negative 4 over t squared. Alright, so that's the integral. And what are the limits? The limits is, lower limit is 1, the upper limit is x. Let's apply the limit. Putting t equal to x. Is that right? Replace your t by x. It will give you 4x plus 4 over x. That is the upper limit value. Minus t is replaced by 1. That will be 4 plus 4 over 1. Is that right? 4 times 1 plus 4 over 1 is 4. And what is that equal to? Right. Can you write it in the simplified form? Can you write it as 4x minus 8, that is 8, is that right? 4x minus 8 plus 4 over x. So that will be 4x minus 8 plus 4 over x. Now, this is a of x. And we have been told, after obtaining this function, find its asymptotic behavior. What does that mean? What is an asymptote all about? Well, in this case, the asymptote occurs when x approaches 0 as well as when x approaches infinity. But you notice that when x approaches infinity, this quantity will be 0. That means the function value will reduce to 4x minus 8 at very large values of x. That means this 4x minus 8 is the oblique asymptote, the slant asymptote. And at x equal to 0, you have a vertical asymptote. So you get the asymptotic behavior. We've got two asymptotes. What are they? X equal to 0 is a vertical asymptote. Got a vertical asymptote. And the slant asymptote is y equal to 4x minus 8. Now this is the asymptotic behavior. Can you draw the graph of this function using these two asymptotes? We have done these kind of questions before. Let me see if anybody can do that. This is our function a of x equal to 4x minus 8 plus 4 over x. And that gives you x equal to 0 is a vertical asymptote, and y equal to 4x minus 8 is a slant asymptote. What it tells you is that when x gets closer and closer to 0, the function goes to positive infinity. Is that right? It must be, because as x gets very large, it must go to positive infinity. So when x gets very close to 0, y must go to positive infinity. And as x gets very large, the function must go very close to the graph of y equal to 4x minus 8. Can you first of all draw this asymptote? What is y equal to 4x minus 8? What is the graph of that? Well, let's do the axis. That's your x and y axis. How do you draw the graph of y equal to 4x minus 8? Remember, y equal to x is this line. Y equal to 4x, it is, slope is 4, so it will be a line something like this. And minus 8 means you go down 8 steps. But it's much easier if you can find the x-intercept of this. What is the x-intercept of this? 4x minus 8 equal to 0 gives you x equal to 2. Is that right? So you got x equal to 2. This is the x-intercept. What's the y-intercept? Y-intercept occurs when x equals 0. It's negative 8. So that would be 1, 2, 3, 4, 5, 6, 7, 8. That's negative 8. So this is the y-intercept. That is the x-intercept. And so your graph of y equal to 4x minus 8 is now this. My ruler is now standing straight, so I have trouble doing that. That is the graph of y equal to 4x minus 8. Now, this is the slant asymptote. Now, how is the graph going to look like? First of all, this is the one that we need to graph. Now, Can you find the x-intercept of this? X-intercept is obtained by setting this equal to 0. Can you set that equal to 0? Let's do that quickly because my time is running out. 4x minus 8 plus 4 over x will give you, simplify that, it will be 4x squared minus 8x plus 4 all over x. And when this equal to 0, the numerator equal to 0. And I'm going to simplify this. You can see 4 is the common denominator, the common factor. 4 times x squared minus 2x plus 2 divided by 4 equal to 0. X squared minus 2x minus 2 is x minus 1 all squared. When you set it equal to 0, you get x equal to 1 is an x-intercept. It's a multiplicity 2. So x equal to 1 is an x-intercept. And as x gets closer and closer to 0, the graph goes to positive infinity. So the graph will come from positive infinity. It will touch the x-axis here. How do you know it just touches and doesn't cross? Now remember, x minus 1 squared equal to 0 gives you x equal to 1 twice is of multiplicity 2. When you have an x-intercept of multiplicity 2, at that intercept the graph will not cross. It will touch and go back. So it will touch at x equal to 2 and go back. And for large values of x, it must go along the slant asymptote. That is the graph of that function. Well, I think we spent a considerable amount of time talking about the fundamental theorem of calculus, and you need to know how to use that to evaluate the definite integrals.